Faith. Hello.
Yes.
We can continue. So I just want to wind up. So we are saying pseudocode is an example of a design tool. In pseudocode, we just come up with a program design by basically describing the activities involved using the normal English language, but we have to follow the syntax of a given programming language. You have to follow the syntax of a given programming language. So that's what we call pseudocode. So here is an example. You can see initialize total mark. Total will be cumulative. It's going to accumulate with time. Counter is also another variable that will give us intervals. At each interval, we repeat the activity of entering what we call the average score. Now, we are setting them to start at 0, total marks to start at 0. So repeat is a keyword. Repeat means we perform an operation several times. Performing an operation several times. So read input. It means you enter score number 1. Score number 1 for student number 1. Add mark to total. You say that score that you've entered, you add it to the total. And total was 0. So 0 plus, let's say if someone enters 50, same as 0 plus 50, now total marks becomes 50. Then increase counter by 1. How do you increase counter by 1? Counter was 0. You say counter is equals to counter plus 1. 0 plus 1, counter becomes 1. We are doing that so that counter gives us another interval, so that we can repeat another operation. Once counter becomes 1, we go back, add, read another input. We enter another score like 60. Now it comes to this line, add 60 to total mark. Total mark was 50. The score that someone has entered is now 60. So the total score becomes 50 plus 60, which is 110. Then it comes to here, increase counter by 1. So count is equals to 1 plus 1, counter becomes 2. 2 is still below 10. So we repeat another operation, read another input. Someone enters, let's say 80. So it will add 80 to total mark. Total mark is 110. 110 plus 80, we come up with 90. Total becomes 190, 190. Then it will increase counter by 1 again. 2 plus 1, because counter was at 2. 2 plus 1, counter becomes 3. We go back because 3 is below 10. So we are going to repeat this operation of reading a mark, adding that mark to the final total, then increasing or incrementing the counter until counter becomes 10. When counter reaches 10, we will stop. We don't repeat that operation again. It means we have the 10 values for the 10 students. Then that total mark that we have got, we take it, we divide by 10, calculate the average. Because we are saying calculating average is done once. We take total score, divide by 10 students. So these activities, the 3 activities here, they are the ones that are being repeated. We are repeating them by using a timer, using a stopwatch, which we are giving it a variable counter. And this counter we are setting to start at 0, we increase by 1 until it reaches 10. Between 0 and 10, we'll have 10 repetitions, enabling us to acquire 10 values for the 10 students, add them 10 times to come up with total score, and divide total score by 10 students so that we come up with the total average score. Then we display. So we are saying basically, for you to understand, I will do another video for this program design tool. For you to understand this, imagine of a problem and come up with a pseudocode. Let's say I want to write a pseudocode to return area of a rectangle. How am I going to form it? So line 1, I can say begin. Line 2, I can declare variables. The variables are one in radius, another one is width, another one in length. Line 3, I can say enter length or get inputs. One input is length, another one is width. Another line I can form is say compute area. How do you compute area? You say area is equals to length times width. Then the last line is display area. So you just imagine a problem, then try to come up with a pseudocode. You just write your lines, starting from line you're inputting up to line you're outputting, but your pseudocode lazima ikuwe na begin na end. The last line is end ama stop. The first line is always begin ama start. Once you begin, kama inaanza na variables, neka variables, but I will do other pseudocodes. Then we go to another tool, which is basically a flowchart. A flowchart uses special diagrams, symbols, which are graphical in nature to represent what you call a plan. And each symbol represents an activity. An activity can be one, starting or stopping is an activity. There's a symbol you start and stop. Process is a rectangle. Process means converting data into information. Come on, add numbers, divide, compare, that is process. Input and output is shape. Inputting activity and outputting activity. Whatever you're inputting, whatever you're outputting, unaweka ndani ya shape. Decision is making choices. Comparing two or more data items is done using diamond for making a choice. Arrows ni kushow flow of direction in terms of control inaenda aje. Logic, reasoning inafanyika aje from top down. So arrows si ati na point to chini peke yake, kuna ya right, kuna ya left, kuna ya up, kuna ya down. Then this is what we call connectors. We have on page connector connects two or more parts of a flowchart which are on the same page. On the same page, two flowcharts which are on the same page. If I want to connect them, I use this connector. This one is known as off-page connector, which connects two different flowcharts which are spread over different pages. One is on page 1, mine iko page 2. So on page 1 nikichora nikishamaliza mwisho, I put this connector. Then when I come to page 2, I also start with this connector. Then you have what you call guidelines before you come up with a flowchart. You must start with a start symbol. You must end with a stop symbol. Higher. In terms of page connectors, you have to reference them using numbers. You put a number, this page connector number 1, page connector number 2. If your flowchart has several pages. Same to off page. You identify them using letters. You define them using letters. The general flow of logic is done by using the arrows. The arrows. The arrows, one is top, bottom, left, and right arrows. Then arrows should not cross each other. They should not cross each other. You have to apply also spacing. These are factors to consider when drawing a flowchart. Labeling, you have to label your flowcharts or symbols correctly. They must be accurate symbols when you are drawing them. If you're drawing a rectangle, draw a shape of a rectangle. If you're drawing a diamond, draw a shape of a diamond. Correct symbols. Then what you call sequence of symbols in terms of order from top moving downwards. Top moving downwards, we define the operations, the activities, how they are performed. Label, put your symbols in that given order. Then you have to be neat so that your design tool can be representable. So basically, those are what you call design tools. Here is an example. These are programs that can divide two numbers. So we have a symbol for start. Then you have take number 1 and number 2. These are symbol for entering number 1 and number 2. We get average. You say average is equals to number 1 plus number 2 divided by 2. This is basically a total divided by 2. We are using a rectangle, which is a process. Print average, then stop. That's an example of a flowchart for coming up with the division quotient of two numbers. Another flowchart to return area of a circle. Start. We say input radius, calculate area, Area is equal to 3.1, which is pi times radius. Then print area, stop. We have another one. Flowchart to determine the largest among two numbers. Whenever we involve the concept of making choices, we have to use the diamond. When you're making choices, you have to use diamond. Here we are making choices. We are choosing between number 2 and number 1. Which one is the largest? Either number 1 as being the largest or number 2. So we enter two numbers. Then we're using a test. This test is a logical test. We say, is number 1, which is A, greater than number 2, which is B? Is A greater than B? A is number 1, B is number 2. Which is true, we say that A is the largest. We display that A, meaning the largest. Which is not, it means we display that B is the largest. So here we want to make choices between displaying that A is the largest or B is the largest by using what we call this condition. And such a condition is known as a logical test, which returns either yes or no. Then it will connect to stop. Another example of a flowchart is basically when we are repeating operations, when you are performing some activities several times. For example, you want to print a series of even numbers between 1 and 100. Even number between 1 and 100. And basically, an even number is a number that is divisible by itself and 2. So we are saying start, we are saying num is a counter, and this counter starting at 1. Now we are saying while num is equals to 100, if num is equal to 100, we stop. But if it's not 100, we come and we say num is equal to num plus 1. Meaning 1 plus 1, we get 2. With that 2, we are going with it. We take now 2 divided by 2. The remainder is what? This is division, but this division is dividing numbers and giving us the remainder. This symbol of percentage symbol. These are percentage symbol here. So if num modulus, we call it modulus 2, meaning it will divide a number with another one and give you the remainder. So if number we get after increasing by 1, we modulus 2, the remainder is 0. Nothing remains. It means that number is even. We print it. But if the remainder is not 0, we stop. We also come back and add. So we continue that way until number reaches 100. What we are repeating is checking if that number is divisible by 0 and incrementing so that we come up with another number, another interval. So basically, those are examples of what we call design tools. But I'm going to do a video, then I'll post on that lesson of program design tools. I'm going to do a video of pseudocode and flowchart because those are the most common. We have other tools, but I'm not going to look at those tools because they're not examinable at your level. So I'm picking pseudocode and flowchart. So I'm doing a video of pseudocode and flowchart. I will add in your platform on that lesson of program design tools. Then you can access and watch it. So any question? Any question? Joseph?
Yes.
You have a question?
No. Kuna unit ngapi? Ziko ngapi zote total?
Unafanya diploma ama certificate?
Diploma.
Diploma module 2, module 1. Size
Module 1.
You are learning ICT and ethics.
Yes.
Structured programming. Computational mathematics.
Yes.
Operating system.
Yes.
Communication skills. And which one else? Computer applications 1. Then lastly is
computer applications 1.
Then lastly the entrepreneurship skills. So uko na 7 units diploma. 1 is structured programming. Number 2 is operating system. Number 3, computational mathematics. Number 4, computer applications 1. Number 5, IT and ethics. Then you have entrepreneurship. Guiding us Jataja. First question 7.
ICT and ethics, structure programming, computation mathematics, operating system, communication skills, computer application 1, entrepreneurship. Sawa.
Hizo.
Sawa.
So to meet in our next Zoom class takuwa Thursday. Now, in case
Yes.
can inform others, in case you may fail to attend this Zoom, you can also attend another Zoom on Saturday. Have another Zoom on Saturday. I guess it's 10 to 11 up.
10 to 11.
And
that's this 12.
Yeah.
That's day on 12.
Yes.
At 12. That's day.
Thursday is at 12, but Saturday at 10 to 11. So 10 to 11. The Saturday. So Saturday niko kwa programming languages huko, but hii niko mbele kidogo. But for pseudocode and the flowchart, I'm doing a video quiz, basically focus on pseudocode na flowcharts.
Na flowchart
sawa.
Okay.
Okay, you too.
Bye.